I don't know. They've made a lot of changes.
Did you make some change in here?
Sorry, I don't care.
I have 21 cents.
All right, so today you're gonna want to have out your formula sheet that has the unit circle on it. Okay, when you get to graphing, you're gonna want to have that. And so today what we're gonna learn is how to graph the three easier of the trig functions, okay? Sine and cosine are not bad at all to graph. Tangent is a little bit worse. And then cotangent is like tangent. We're gonna do cotangent tomorrow, along with cosecant and secant. So between today and tomorrow, you're gonna see how to graph all of them, okay? All right, so first of all, when you decide how do you graph this? Generally, what I do is I go to my unit circle, if you didn't know, okay? And when you're doing sine, so this one right here is sine, the way that you can tell how to graph it is by looking at your unit circle if you don't know them. As you get good at this, you're not going to have to look at your unit circle. You're going to know how to graph these. But at first, the sine of 90, remember sine of 0, sorry, sine is the second one in the parentheses. So sine at 0 is 0. Up here, sine goes to 1. At 180, sine goes back to 0. Down here at 270, sine goes to -1. And then as we get back to 360, sine is at 0 again. So if you look up here, that's where they're getting these points from. Sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, sine of 360 is 0. From here to here is what's called a period or one cycle. And we talked about that we had some questions on that in our last test, like where do things repeat itself? So if you kept on with this, this would just keep repeating itself, okay? I don't think they'll ask you for the domain or range, but if they did, for sine and cosine, it's all real numbers. There's no place that has undefined numbers, whereas all the rest of them, other than sine and cosine, do have that. For the range, if it's just a normal sine function, the biggest number it can have is 1, smallest is -1. But we're going to look at things today that don't have, they're not just a regular sine function. We're going to be changing the number in front here, which also changes how high and low your sine function goes. And then again, the period is 360 degrees. In this first section, when they do the graphing, they're only doing it in degrees, which I think is easier. And then in tomorrow's section, no, tomorrow we're still in degrees. We're in the same section tomorrow, but then on Wednesday and Thursday, they have where sometimes you graph using the degrees, sometimes you graph using like 0, pi, pi over 2, 3 pi over 2, and 2 pi. So, well, but for this section, it's only in degrees. Y equals cosine of theta. For that, again, you would look at your unit circle if it's for your first time. At 0 degrees, the cosine is the first thing in parentheses. So at 0, cosine starts up at 1. Then at 90 degrees, it's going to go down to 0. At 180 degrees, it goes down to -1. At 270, it's back up to 0. And at 360, it's up at 1. So if you look here, the normal period for cosine would be from here to here, 360 degrees. And this one does not start at 0. It starts up at 1, goes all the way down, comes back up at 1. That's one period of the cosine function. All right, so the the way we're gonna start this is we're just gonna graph a sine function, just so you can get used to it. The book starts you right away doing different amplitudes and different periods, but I thought it would be good for you to just see what it's like to graph just one function, one sine. So again, sine of 0, we'd look at this number here. Sine of 0 starts at 0, okay? Then you'd go to sine of 90, and remember it's the second thing, so at 90, now here's another thing. When you do this, you decide what each of these are going to be. You could make this 1 and only have your graph go up to here. You could say, okay, I'm going to make this 1 and this 2 on this graph, and then this is -1 and this is -2. You kind of decide what you want those to be. And I think that's what I'm going to do for this. I'm going to do every other one as 1. So at sine 90, it goes up to 1. At sine 180, it's at 0. At sine 270, it's at -1 down here. And back at sine of 0 or 360, it's at 0. And then you just draw that curve through it, okay? Now, because your graph keeps going in this direction, you'd have to fill it. So what you would do is just kind of continue that pattern. It would have to come down, then at -180, it would be here. At 270, it would be here. At 360, here. Okay, so you always want to have your entire graph covered. All right, so that is the sine function. The second one we're going to look at is the cosine function. Okay, so this is just a plain cosine function, and again, you can cheat and look at your unit circle. Cosine is always the first thing, and cosine, again, I'm going to make this 1 and 2, and this -1 and -2, but you certainly could have called this just 1 up here. That would have been fine. So at 0 degrees, cosine is 1. At 90 degrees, cosine is 0. At 180 degrees, cosine is that first thing, so it's at -1. At 270, cosine is 0. And at 360 again, cosine is going to be 1. So this is a complete period for cosine, okay? And then if you kept that pattern going, it's going to look like that. Okay, now, right away what they have you start doing is making changes to the normal sine function and the normal cosine function. And one way they can do that, if they put a number in front of sine theta or cosine theta, they're changing what's called the amplitude of the graph. And the amplitude is the distance, this is called your midline right here. And amplitude is the distance from your midline to one of the peaks of your graph, or the midline to, this is called the trough of your graph, okay? So one of those two. It's just basically how high is your graph from the midline, okay? So when you look at this, this is the sine function, one where it has just a normal amplitude of 1. It can have an amplitude of 2, where it's going up to 2. Amplitude of 3, so it's going up to that. Amplitude of 4. So that's 4 different graphs. They're all the sine graph, just with different amplitudes. And this shows you what we'll be doing tomorrow. Instead of degrees, we'll have radian units on some of our problems. And this has the radians rather than degrees. Okay, so the second thing that they can change on a graph is the period. And we talked about, like, one period on cosine is this much. Period is 360 degrees, okay? Same thing with the sine graph. You don't have to do this on it, but just to show you. One period on a sine graph is 360 degrees, okay? But what they can do is they can change how many sine functions you fit on a graph by putting a number after the sine in front of x. And actually ours, sometimes they're x, sometimes they're theta. Theta and x here would be the same thing. So the number in front changes how tall and low that a graph will go. The number in front of your x or your theta, that changes how many periods you can have on a graph, okay? So if you look here, period is again the distance from any two similar spots, like here and here would be one period. You could say, okay, I'm going to go from this spot to this spot. That's one period, okay? Amplitude, again, is this distance, okay? So when you're doing sine, this would be like a generic equation for something that has changed the amplitude and changed the period. If you're given this and they ask you to find the new period, what you do is you take 360 divided by, now they have the absolute value of b, but you won't see it as a negative number, so you just take 360 divided by that. So say that I gave you y equals 2 sine of 4 theta. This 2 changes how high my graph is going to go. Instead of going up to 1, it's going to go up to 2 and down to -2 and up to 2 and down to -2. This 4, what that does is I take 360 divided by that. And what that means is instead of my sine going through 360 degrees, I have to do the whole sine function in 90 degrees. So I'd actually have 4 sine functions between 0 and 360. Okay? Same thing with cosine. You would just take 360 divided by whatever that is. So let's go here. And these we don't have to graph. They just are asking us, what is our new amplitude and what is our new period? Okay? So amplitude is just the absolute value of what's in front. Okay? And I have not seen one that I'm going to assign that's negative because you have to graph that a little bit different. So we are just going to say our amplitude is 3. Okay? And for the period, you would just take 360 divided by whatever is in front of your x or theta. They're the same thing. And 360 divided by 5 is 72 degrees. So what that means is on a graph from 0 to 72 degrees, you would have your whole sine function. And I'll show you how to do that. 72 wouldn't actually be a very easy one to graph, to be honest. Now, if we look at this one, our amplitude is going to be 4. How does that change the graph? Yep, yep. The height. So instead of going up to, what do we normally go up to? 1, we'd go up to 4 and down to -4. Yep, good. Then to find the period, the new period, we take 360 divided by a half. Okay. Now, how I would think about this, if you're taking 360 divided by, you could just go 360 divided by 0.5. That'd probably be easiest. But sometimes you'll get like 1/3 too. So what I would do, you could go 360 divided by parenthesis 1 divided by 3. Okay. Or what you can think of there, dividing by a half is the same thing as multiplying by its reciprocal. So we'd multiply it by 2/1, and it would be 720 degrees. So what that would look like, say this is 360 degrees, say this is 720, okay? This would be 180. This would be 540. So if this was a cosine function, okay, number one, it would go up to 4. And down to -4. And it's cosine, so it starts up. And then at 720, it would end here. Halfway between these two, which is at 360, it would be down at -4. And then halfway between these, it would cross the x-axis. Halfway between these, it would cross the x-axis. And it would look like that. Okay? So that would mean that your entire period is from 0 to 360, or 0 to 720, sorry. Okay, so we are going to try to graph some sine functions that have changed amplitudes and changed periods. Now this one, only one of the things is changed. Which one's changed here? Amplitude, and that's the easiest one. The period, there's nothing in front here, so our period is still 360 degrees. Okay, that does not change. So sine, if you guys remember, does sine start at 0 or does sine start up at 1? It starts at 0, okay? And now I'm going to do 1 and 2 like this, but you would not have to do this. You could call this 1 and this 2, that would be fine. But sine is still going to go to 360. And then, so if you know your period is from 0 to 360, you know halfway in between there, it's going to be at the x-axis, okay? And then where would 90 be? Would it be up at 1 or down at -1? You know? Oh, up at 2, yes, sorry. Up at 2. And then at 270, it would be down at -2, okay? So my amplitude is the only thing that changes here. And then if I went backwards here, what do you think would happen at -180? Get that it would be right at 0, and at -360 at 0. Where do you think it would be here? Up here or down here? It would be up, and then here it would be, oops, I didn't make that up or down. So here would be my graph. Okay, so now if we look down here, is this one's amplitude changed at all? No. And again, I'm going to make this 1 and this -1. So my amplitude in this one is just 1. Okay? Then what we're going to do is look at, does our period shift? And it's 360 divided by what's in front of theta, which is 4, and that's 90 degrees. So what that means, this one's cosine, and our whole cosine graph has to go between 0 and 90. Okay? So when you start out at 0, does cosine start up at 1 or does it start at 0? It starts up at 1, cosine does. Now, the whole thing has to be done by 90 degrees. So where would 90 be? Doesn't cosine go down and back up? So do you guys get that it would be back up there? Okay. And then halfway in between here, where do you think our point would be? Wouldn't it have to be down here for it to be an entire cosine graph? It would have to be down here. And then halfway between here, it would cross the x-axis, and halfway between here, it would cross the x-axis. So this cosine function looks like that. So it's shrunk by like 4 times. Then you would just want to keep doing that, you know, so what you would do is skip 2, put a dot, skip 2, put a dot, skip 2, put a dot for each of these. And then the same thing down here, skip 2. So you would go like that there. And then going backwards, we could skip 1, put a dot, skip 1, put a dot, skip 1, put a dot, skip 1, put a dot. And our graph would look like this. So when B is 4, what that means is you're going to have 4 cosine functions in the same spot that you would normally have 1. If it was 5, you'd have 5 cosine functions. So if you notice, I have 1, 2, 3, 4 in from 0 to 360 degrees. Okay. Now, let's look at another one like this. Now this, we're changing both the amplitude and we're changing the period. So our amplitude is going to be 3. Our period is going to be 360 divided by B, which is 2, and that's 180 degrees. Okay, so this time I have to go up to 3 and down to -3. So when I number these, I'm going to go by ones. Now, my entire sine function has to go between 0 and 180. So it's going to start, do you guys get that sine starts at 0? And it's going to end at 180. Okay, what do you think is going to happen at 90? It would actually be an intercept. And then what do you think would happen halfway here at 45? It would go up to 3. And then what would happen between 90 and 180, which is 135? It would go down to -3. So it would be, so there's an entire sine function between 0 and 180. And then you're going to have an x-intercept here, oops, and here. And then between these two, it's going to go up to 3. Between these two, it's going to go down to -3. And notice we do have 2 complete sine functions between 0 and 360. And then we could go backwards here. We have an x-intercept at 90, 180, 270, 360. This would be up, this would be down, this would be up, this would be down. Is everybody okay with that? Okay. So now if we look at this one, our amplitude is going to be 3/4 or 0.75. And it doesn't matter how you write that. Probably what I would do here is just make this a 1, this a 0.5 or 1/2. And do you guys get then this would be 0.75, this would be 0.25? Bless you. I'm going to just leave it as a decimal. Okay. And then for our period, it's going to be 360 divided by 1/2. And 360 divided by 1/2, if I do that, remember that's the same as multiplying by the reciprocal of 1/2, which is 2/1. So my period for my sine function is going to take 720 degrees. So what's going to happen between 0 and 360? How much of my graph of my period am I going to have there? Half of it. So I'm only going to have half of my sine, or is this cosine? Cosine. I'm only going to have half of it here. Okay. Now cosine, our amplitude is 0.75. With cosine, do you start up at 0.75 or do you start at the origin? Up. You start up here. Okay. Now this one we're going to have to kind of think about, and one of the things that you can think about is when you plot these points, you're going to always have one point at the start of the cycle. And you guys get that the end of the cycle would be way over here at 720. Okay. And the middle of our cycle, where's the midpoint if it's from 0 to 720? At 360. So where do you think our graph is going to be? Think of a cosine graph. Isn't this the midpoint, right? So what do you think is going to happen at 360? Where would we be? At negative 0.75? It's not going to be I'm going to just draw it right over here. Okay. Then what do you think is going to be halfway in between here at 180? Isn't that going to be where we're going to cross the x-axis? So do you get that it would look like this? Okay. And then if we could continue it, it would go up here. All right. Now, what do you think is going to happen at negative 180? It's going to be at 0. And what do you think is going to happen at negative 360? It's going to be down here. So you get that that would be your graph? Okay. All right. Now